Let's take this example of a sentence. I think 73 is a prime number, period, which ends the sentence, which also ends the input. And if you look here, by the rules of our problem, I is a word, think is a word, 73 is not a word. A word is nothing but a sequence of alphabetic characters. 73 is not one. Is a word, A is a word, prime is a word, number is a word. So there are 1, 2, 3, 4, 5, 6 words here. So we expect this input to produce the output 6. How do we figure out a word? Let's take the example of think here. Before the letter T, there is a space character. So the fact that we are going from a non-word character, only alphabetic characters are permitted inside words, so space is not one of those characters. So we are not actually looking at a word when we are on a space character. So the fact that we are going from a non-word character to a word character, like, of course, just letters, in this case the letter T, means that we have a new word. So we look at two characters in sequence, the previous character and the next character. If the previous character is not alphabetic and the next character is alphabetic, then we have a new word. We can increment a counter. So that would be a rule. If previous character is not a letter and the next character is a letter, increment number of words. Does that rule work? After we hit the T and then move on to the H, the previous character here is a letter, so this part of the condition is not going to be satisfied, so we will not increment number of words. So we will be okay with H, I, N, K. We will not be incrementing number of words in any while we are on any of these letters. Eventually we will have gone from think to the next character, which is a space, and we will be having the previous character a letter. So again, we will not be incrementing number of words. What happens when we are on 7? Here the previous character is a space, so it is not a letter, so that part is actually satisfied. But the next character is not a letter, so we will not be incrementing number of words here as well. What about the end of this sentence? We would have incremented number of words at this point when we go from the space between prime and number into the letter N. That is, as we get into the word number. Because the previous character is not a letter, which is a space, and the next character is N, so we would have incremented number of words. And we will not increment number of words anywhere here. And eventually when we get a period, we should get out of the loop. And what is the situation here? That we already have counted this word. We don't have to do anything. So once we get out of the loop, we just print the number of words. Another way to handle this problem is to count a word as we leave it. For example, again consider this word think. It ends with the letter K, and after reading K we will read the space character. So we know that we are getting a character that cannot be part of a word, and the previous character was a letter, so we are just leaving a word. We can increment number of words. So that would be a totally different approach. So we have a different approach. Count words once we leave them. So the rule would be, if previous character is a letter, and the next character is not a letter, increment number of words. That would be a different approach. But what happens if we hit the period? Now, once we hit the period, we should leave the repeating block. We should leave the loop. So after we leave the loop, we still wouldn't have counted number. So we need to check if the previous character was a letter, and since it is a letter in this case, we would increment the number of words. So there is more work to be done after we leave the loop. So we are not going to worry about this approach. It is a little more complicated. It involves more code. So we are going to just ignore this. Now let us put this rule into practice. Let us now employ this rule to get an algorithm to count the number of words. Obviously, we need variables to store the previous character and the next character. So we need previous character and a next character. Again, take this example of I think 73 is a prime number. The very first character that we read is I, and that begins a word. So we should be able to employ this rule if previous character is not a letter and the next character is a letter. The next character is I, so this part is satisfied. We should somehow make this true at that point so that we can count this as a word. Because we are counting words as they begin, we should be able to count I as a word once we hit the I, not after we leave I. So previous character should be initialized to something other than a letter, and one possibility is to make it a space. So we put a space into previous character. And next character would be equal to the character that we read from the input. And we process this until we hit the character period. While next character is not equal to a period, we should loop, and at the very end we should print number of words. So a number of words has to be initialized to 0, and in each iteration of the loop we should employ this rule that we have up here, and what we need to do is check this. If previous character is not a letter, and next character is a letter, number of words equals number of words plus 1. And what we should do is now read the next character, but then what we have in next character right now would become the previous character. So you'll have previous character equals next character, and next character should be equal to the new character that we have from the input. So what is the idea here? For example, when we start with this sentence, I think 73 is a prime number. Initially, previous character would be equal to space, next character would be equal to I, number of words would be 0, next character is not a period, so we'll come here. If previous character is not a letter, previous character is space, so it is not a letter. Next character is a letter because it is the character I. Number of words would be incremented by 1, so it will become 1, which is correct. Previous character would be set to the value in the next character. What is next character? It is I. So previous character would be equal to I, and next character would be equal to the next character in the input sequence, which is the space character. Next character, we'll go back here. Next character is not equal to a period, and previous character is not a letter, is not satisfied because previous character is I. So this will not be executed. Previous character would be now set to the space character. Next character would be equal to the character T here. Now we go back into this loop and iterate again with previous character equal to space, so it is not a letter. So next character is T, so it is a letter, so a number of words will now become 2. So we are starting the word think.